Order in the court. Would the Accident Investigation Agency please explain the case we are examining today?
Today we are investigating the crash between a car driver, Mr. Garcia, and a truck driver, Miss Wakefield. To get to the bottom of this, we will need to understand the physics behind the car crash. For this car crash, conservation of momentum can be applied, meaning that each car's initial momentum, which is the product of its mass and velocity right before the collision, is equal to its final momentum right after the collision. In terms of force and motion, the cars each experience some frictional force opposite the direction of their net force and motion.
What calculations were you able to make from the data you had?
To find the coefficient of friction for the car, we divided the force required to drag the tire at a constant speed by the weight of the tire. This would be 100 newtons over 130 newtons, which gives us the car's coefficient of friction as 0.769. Since it is given that the truck's tires have a coefficient of friction that is only 70% of the car's tires, multiplying the car's coefficient of friction by 0.7 will get us the truck's coefficient of friction, 0.538.
To find the velocities of the vehicles right after the collision, we use the kinematic equation velocity is equal to the square root of 2 times the acceleration times the displacement. Since the only value we don't have in this equation is acceleration, we found the force and divided it by the mass for each vehicle to solve for acceleration. The force in the car is equal to its coefficient of friction times its weight, which should be 0.769 times 13,600, which equals 10,458.4 newtons. Divide this by the car's mass, which is its weight divided by gravity, and you will get the car's acceleration, which we found to be 7.536 meters per second squared. Plugging this back into the original kinematic equation, and the car's velocity right after the collision is equal to square root of 2 times 7.536, which is the value we just calculated, times 8.2, which was its given displacement. And we found that the velocity right after the collision for the car was 11.12 meters per second. We repeated this similar process for the truck, getting an acceleration of 5.27 meters per second squared, and a velocity right after the collision of 10.77 meters per second.
And to find the velocities of each vehicle right before the collision, I assume you had used the conservation of momentum, since the velocities of both vehicles right before the collision are equal to their velocities after the collision. Solving for the velocity of the car right before the collision, you got 12.51 meters per second. And solving for the velocity of the truck right before the collision, you got 12.78 meters per second.
From all these calculations we made, we concluded that both drivers were at fault. If the car driver, Mr. Garcia, had made a full stop at the intersection, the maximum speed that he would have been traveling at impact would have been 8.83 meters per second, as calculated from the kinematic equation for velocity mentioned earlier. And since the car was traveling according to our calculations at 12.78 meters per second, much faster than 8.83 meters per second, there's no way Mr. Garcia could have made a full stop at the intersection. However, the truck driver, Miss Wakefield, was also in the wrong, as she claimed she braked and was only going 6.7 meters per second at the time of the impact, when in reality our calculations show she was traveling at 12.57 meters per second. Therefore, her claim is also invalid.
Since both parties are at fault, neither will be charged with any offense.